join us gradually.
Okay.
Hello, everyone. Thanks for joining us today. My name is Parisa Izzat-Panahi. I would like to acknowledge the traditional custodians of the land on which I work and live. I pay respect to elders past, present, and emerging. I'm pleased to introduce our keynote speaker for the 21st ArchiTalk today by Patrick Bearle. Patrick is an award winner, practitioner, and also an academic, still contributing to Curtin architecture in different occasions and reviews and so on. One of his notable awards that you all are probably familiar with is for the Pingelly Recreation and Cultural Center in 2019. And I think Patrick will be going to introduce that to us today. He was also the recipient of the Sustainability Award in WA in 2020, and also the national, he's a national finalist for Sustainability Award by Australian Institute of Architects in the same year. So if I wanted to name his awards, I would be just naming them till 12 o'clock. So I just summarize those, and I would like to thank you again, Patrick, for accepting my invite, and hand over to you. Thanks.
Thanks, Parisa. That's very generous. Good morning, everybody. Look, today I want to talk mostly about 3 projects that we've completed in our studio in recent years, all of which are engineered timber, digitally designed and fabricated projects. So mostly what I'll be concentrating on is those 2 things, really: the digital fabrication, design to fabrication, engineered timber, and really what this means to the designer and to the fabricator and the builder. Because it's not the same, it's not business as usual. And this is something which not only architects, but builders and most of the consultant team often find difficult to really wrap their head around at the moment. So let's start off with engineered timber, or mass timber as it's often referred to at the moment. What's all the fuss about? It's not actually that new. Engineered timber's been around for over 100 years in various forms. Plywood is probably the earliest of the engineered timbers, but it's only really in the last 30 or 40 years that plywood and the other early versions of engineered timbers have become, shall we say, reliable and durable. But what this timber is, what engineered timber is, fundamentally is it's predictable. You can count on it to have the same properties today, yesterday, and tomorrow, depending on, and you know, those properties will depend on the provenance of the timber and so on. But because it's reliable, it is, if you like, bankable in all senses of the word, in a way that raw timber or solid timber is not. If you think about how a tree grows, a tall tree, say a 40 or 50 meter tall eucalypt, it's going to wave around more in the wind at the top than it is at the base. It will be more elastic, and therefore there'll be more tension that's grown into the fabric of the timber at the top of the tree than there is at the bottom of the base of the tree. This means that when it's cut into dimensioned lumber, it will behave differently from the top to the bottom, although we do our best to pretend it's actually the same. When we turn that same timber into an engineered timber member, these anomalies are equalized, if you like, over the whole member, and therefore we can be more certain of the physical and mechanical properties of that element.
Sorry, Patrick, for interruption. Did you mean to change your slides or not yet?
I probably did, didn't I? Sorry.
No, that's all
Wait a minute. Let me get this in the right. There we go.
right.
That'll do to start with. I mean, you hardly need a lesson in what these things are, but the most common ones, the LVL, glulam, and CLT, and of course the various versions of I-beams that we use all the time around the place. What this, it allows us to make large buildings. It allows us to emulate structures that we would typically make in steel, probably, but nowadays in timber as well. I'm sorry, I can't switch this damn thing off. Okay, there it goes. I'll just switch it off entirely if I can. So something about telephones and we don't get on very well. Excuse me. So where have we got to? CLT is an interesting one of the current sort of band of timbers, in that it's kind of captured everybody's imagination, in as much as it appears to be a really, really easy material to work with. It's like building a house of cards, or it's often referred to, rather unfortunately, I think, as tilt-up timber, unfortunately, because it actually isn't. It doesn't work like that. But what engineered timbers allowed us to do is to make very complex structures very much more economically than we would have done in the past. So what engineered timber's done is make factory or off-site fabrication using robotic or digitally driven machinery. I'm going to go back a slide, so I don't really want to be there yet. Digitally driven machinery for timber fabrication possible. High-tech machinery requires a high-tech product to be able to effectively do its work. And since the input to the machine is numerically precise or dimensionally precise, the machinery expects or demands a dimensionally precise product to work from. If you're designing to zero tolerance in an engineered timber joint, then the material that is being machined must be able to emulate that level of precision. This, as I said earlier, is a simple factor that most people find hard to accept. Now, native timber, on the other hand, is anything but predictable. Where it grows in the forest, the amount of rainfall it receives, the amount of insolation will determine its growth pattern year by year, season by season. Likewise, the orientation of the land the tree is growing on will affect the growth of the tree and the internal structure of the tree, as will the soil it's growing in and the nutrients available to it. When you cut when you're sizing up a coop for logging, you can identify the passage of long past bushfires, for instance, often identified by a very slight deviation in the line of the trunk. You can see where some infestations have passed through and passed on, often noticeable on the bark of the tree. All of this affects the log in the long term. Now, you deal with that at the sawmill, essentially by wastage. But the deviations and the anomalies that the tree will accumulate are the more direct evidence that we have of why a raw timber, if you like, is less reliable than an engineered product. If we treated our native forests and indeed our plantations with the care that we lavish upon our vineyards, for example, we'd be able to predict the behavior, the mechanical and physical properties of our native timbers as effectively as we can our engineered timber. That is another discussion, but it is an important one, I think, because our native timbers are radically undervalued. They're you know, they have really quite extraordinary properties, durability, density, elasticity, or varied elasticity, and so on. But if we were able to, fire resistance, if we were able to understand what each tree was good for, then we could, or how it had grown and what its mechanical properties were, then we could be looking at using engineered raw timber in much the same way that we use engineered timber. But as I say, that's a discussion for another day. So I'm going to run through 3 projects, as I said, and I want to begin with this one, which was the first sort of major project that we undertook, now finished just about 10 years ago now, the South Hedland Performance Shell. This is an all LVL structure, and I think it surprised us when we succeeded in making it, and the fabricators, for whom it was one of the first complex projects they'd had the opportunity to undertake with some machinery that they recently installed, some fantastic product from Germany called the Hundiger K2. On our side, we've been experimenting at maquette scale and in digital form, in prototype grid shells and so on, really inspired by the wheeled and downland grid shell in the UK by TCA, Ted Cullinan, and Arabs. And that structure was remarkable for the fact that it was built flat and then allowed to slump into its final form using green oak over a number of weeks, obviously. We tried to do the same thing with green carry on a scale that was really too small to realize its success, but it was nevertheless instructive. You know, it's one of those projects that you promise yourself you'll get back to one of these days when you've got time and so a bit of funding to do it. The grid shell, I guess, is sort of remarkable for the way it balances on its plinths, and from the way the primary arcs are formed with 3 layers of short length LVL, which are woven together to generate the curvature. While the underside, the top side is milled to a continuous curve, while the underside is allowed to show how the structure is actually made. Tristan Morgan, who's some of you will know, and who was working with us at the time, was really responsible for all of this modeling and for beginning the kind of trajectory that ATC has taken over the last decade or so. The eventual, if you like, solution to this model, which we'd originally imagined to be a kind of undifferentiated grid, turned out to be something a little different. So there are 7, I think it's 7 arcs that are made up by this 3-layer LVL system, assembled on the ground, lifted into position. The whole thing was assembled and the membrane fixed in a week. And that was kind of the beginning of our introduction to the site advantages of prefabrication and the precision that could be achieved with this design file to fabrication process that we've been working with. Now, getting on to the more recent stuff. So the Pingelly Recreation and Cultural Centre, which ATC began, and then later on we collaborated with IBH to implement the project. For those of you who may be my students in Reunion, who may be joining us on this little excursion, this is a trace of a line from Sweden, where we received the first award for this building, the Architecture of Necessity, in 2019. So the line goes from Sweden to Reunion Island and from Reunion Island to Perth. Kind kind of a little obscure. And then we arrive in Perth, and we go from Perth to Pingelly. It's about 2 hours drive southeast of where we are here. Three seasons, which locals will all be familiar with: the dry brown summer, the slightly less brown spring and autumn, and the green of winter. Pingelly, like many rural towns, it's a little broken down. It's got a lot of quite interesting, but empty or underused buildings. But it has a pretty vibrant community who live off the back of the sheep and the fecundity of wheat. So we began working on this in 2014. It's a very simple in concept. There's a large veranda which acts as the kind of the internal corridors of all the buildings, because there aren't any internal corridors. It also acts as the grandstand to the playing fields up here. Then there's 2 main buildings. There's a sports hall and a cultural centre, and the kind of main entrance off the town. This is located in a kind of sporting complex of the town, and we did count up at one point that all the population of the town must, for the number of subscriptions there were to the various different sporting clubs, the population of the Shire all had to play at least 6 different sports, which was a little a bit of an eye-opener. The building needed to be as passively heated and cooled as possible. Running costs, obviously, for a small community are a major issue. There it is located on the site: the footy oval, cricket oval, swimming pools, all the previous sporting facilities all dotted around here, which have now been removed, and the building, and of course the necessary lawn bowls fields down here. The original, this is some shots of the original digital model, which was built up in Rhino by Tobias Bearle and Tara Moore. And these, I've put them in because when you see the photographs of the finished object, you'll see that very little changed along the way. Introducing an all timber building to WA was a kind of a 2-year-long process, really, I suppose. And there's just a quick sort of run through there of the kinds of arguments that we had to overcome in persuading the Shire that this was actually a feasible and a very worthwhile operation for them. As it was, they got a building which for which the nearest non-conforming, therefore steel based tender came in at $1.5 million more expensive than the timber than our building. So that sort of nailed one thing fairly early on, that there is a significant economy to be had from designing and building this way. I want to run through the sort of process a little bit. So I guess this slide is pretty self-evident. The sort of function centre and cultural centre over here, the indoor sports hall, changing rooms, and then sort of ancillary club rooms and so on down here and across here. The building sits up on stumps. We really didn't want to have to bring in lots of fill to level off the ground. The ground actually falls away on one side, so there's kind of minimal amount of concrete in there, just holding the thing down, stopping it blowing over effectively. So there's the long base, the large sort of base deck, sitting on, as I say, sitting on stumps. The 2 major volumes sitting over the top of it, and then the veranda volume that links everything together and provides, let's say, circulation, grandstand, and just general social space for the town. Now, the 2 parts to this, so half the building is native timber. Most of what you see is actually native timber. So the cladding, the decking, a lot of the internal paneling, is all WA plantation grown yellow stringy bark, or Eucalyptus mulleriana. We cut about 1,000 tons, which equates to 350 cubic meters of this material for this project, which we were able to buy directly from the state forests, and process it to the sizes and the lengths that we needed, as opposed to going and buying it off the shelf. This already gave us a reasonable advantage in both in cost and in recovery from the native timber. So we were getting a recovery of around 40% out of the log delivery on this job, as opposed to a typical dimensioned lumber recovery of around 30%, 32%. And that's because we were cutting to what we needed rather than cutting to a specification. They were good logs by and large, good size, and very straight. As I say, these trees grow to sort of 45 to 50 meters. The longest logs we cut were 8 meters. There were some 6 meter lengths that we needed, and that was as long as we could carry on the sawmill. The skill of the sawsman, of course, is paramount in this kind of operation. That's one of the 8 meter logs going through, and that's stage one of the seasoning process. So this is the logs all slabbed up, and we're leaving them outside as long as we possibly can before we put them through a kilning process. While that's going on, we're preparing the final model, and as it happens, the structural model is in fact the architectural model in this case. Obviously, with some embellishments that are evident in this version here. But the point that I want to make is that this building was designed essentially in Rhino. The Rhino interfaces almost seamlessly with CADWorks that the fabrication engineers use to then assign properties and the milling process through this amazing machine, the Hundiker K2, which will cut, shape, mold, route, drill precisely each member that is delivered to it. This was all carried out by Timber-Built Solutions in Melbourne at that time. And one of the really exciting things about what we're doing now, what we're able to do now, is that Timber-Built Solutions is now Timber-Built Australia and is located here in Western Australia. So we actually have not only some of the most sophisticated machinery for milling timber that's available in the marketplace now, but we also have the skills and the plant in WA. So it gives us a great advantage in our capability in this state. There's just a couple of sort of shots of the kinds of things that the machine will turn out for you. These are cross-bracing members, which you'll see later on. The floor deck, the bearers and the joists are coplanar. The joists drop into these dovetail mortises. There's no mechanical fixings at all, so it's just a placement process to go through. There's some more of it up there, and these are some of the ceiling cassettes, the smaller pieces down here. Now, this building is all LVL, laminated veneer lumber. It's an LVL that's produced in New Zealand by Carter Holt Harvey from radiata pine. And the great thing about this product is that it is it is predictable in dimension. When you order a 90mm slab or billet of it, you get a 90mm billet. If you don't, you can't actually design and fabricate to the precision that you need to in order to put these sort of scale of buildings together. If a material deviates by 2 or 3 millimeters, you're not going to get the fit that you need when you put two pieces together, so we say to put a bolt through them. If a 10mm bolt will not go through a hole that's offset by 2 millimeters. So it has to be precise, and it has to be machined to that absolute precision. The other interesting thing about the structure of this building is that I said it's all LVL. Well, yes, that's true, but it's LVL box construction over the main spans, the big spans, which you can see here in the process of parts of them in the process of being assembled, and they're the kind of the whole kit of column and rafter parts being assembled. This is the sports hall, which has a 29-meter span, excuse me, and the rafters are made up in 3 sections. So you've got these joining splines that you see here with the fixing points. That's the column. That's the little fixing point for the steel plate that joins it to the concrete plinth. And that's what it looks like when it's assembled. So there's the whole 3-part rafter and column assembly. And this is actually just, this was the very first set of rafters and purlins that we dropped into position on the columns. And these casings on the outside actually carry very long bolts that you can just see this character here, threading down through the hole here, as you can see it in that diagram, and dropping onto the nut at the bottom. These little red guys are the locating pins that we use when we're dropping the rafter onto the column. That's really all they're there for. And that's really because of this is a portal frame, so that's the key joint in this whole structure. A little bit clearer in this one, you can see where the bolts are coming through from the 2 sets of casings, and you can see the little tiny 8 and 12 mil plate sitting down there at the bottom, where it's joined onto the concrete plinth. Just as again on this note of why the rapidity of assembly on site. So this all arrived obviously kind of flat packed, if you like, from Melbourne. You can't economically transport a roof section that's 29 meters long and 6.5 meters wide across the Nullarbor. So this all came over in sticks. It's assembled on the ground down here, and then all of this that you see in this slide, including this one that's still on the ground here, was put up in 1 day. And using one crane with a big spreader. There we are from about the same time. You can see we're getting on late in the day here from the shadows, and laid out on the ground over here are the assembled wall sections, which will go on the upper part of the wall on this side. As the next stage of the construction, there we are. That's actually 2 of these went up on the first day, and by then it was too dark to see any more. What comes out of the factory is not only the drawings that tell the contractor how to assemble these sections, but also how to sling them, so that the thing doesn't kind of tear itself apart because you're lifting it up on from the wrong point. So the fabricator goes a very long way towards, if you like, assisting with the assembly process, with the construction process on site. The purlins here are all I-joists. They're screwed directly to little blocks that are located on the rafters. Again, that's done in the factory. So when you come on site, all you're doing is you're lifting up a pre-cut I-joist and you're dropping it in with a couple of screws and then putting the continuity strap over the top. So the assembly process is really pretty straightforward. That slide gives you a kind of pretty full run of the whole process from the axis, the center line of the rafter through to the column head here, and that's that wall section that stands up and hides everything behind it. That's obviously the rafter section that you can see up there. So this is really the first time that the town, when we got this structure up, the first time the town had really seen what they were going to get. And the town sits in a valley. We're on one hill on one side of the valley. The sports centre is on the other side of the valley. So all of a sudden this thing pops up on the other side of town. We're actually just standing outside the primary school in this shot. I talked about the thing being the whole building being set up on a structural deck on stumps over ground of varying depths. A couple of reasons for this. One, obviously, was that we didn't want to bring in fill to level the site. The other was that if we're using a timber deck, timber structured deck, we need plenty of air around it, and we need to be able to ensure that we can inspect that undercroft for any likely termite infiltration. Those of you who are not familiar with Australian conditions, we have termite problems here, and so we have to go to some lengths to make sure that we can design out any access routes that termites might choose to explore. And although all the timber is treated, you can never be sure that you're going to keep a termite out with a little bit of treated timber. So this gives you an idea of two things. There's a very regular grid applied across the building, and there are obviously different kinds of stumping systems according to the load that's coming down on top of it. And again, it's another drawing out of the factory that really takes apart the design drawings and reassembles them in such a way that the builder has got a map of how to put this stuff together when he gets it on site. So there'll be an overall drawing like this. This is of the cultural centre, the second building, if you like, which has a variety of structural parts. There's more conventional ladder trusses or stick trusses, as well as some box trusses that run through here, because the spans are all different. Then having, this drawing will then be taken apart into a series of smaller drawings that show them the assembly process for each part. So coming back to the building getting a little bit more progressed, this is the veranda zone, where this column line is set back 1.5 meters from, well, it's actually just over 1.5 meters from the edge of the deck, and that should be about, and it's proved to be about right, the sort of maximum line of penetration of rain onto the deck. The aim on this building was really to shelter as much of the exterior timber as we can from the elements, and consequently, that's obviously aided by the verandas. Where we can't do that, we simply use a much heavier duty section of timber, essentially building in a sacrificial layer for weathering as the elements kind of do their thing on the timber surface. This drawing's in here really. This is a section through the sports hall, and this bit down here is the concrete ramp of the main entry to the building. And one of the issues there is that we obviously need a drainage grill along here, but we can't afford to have anything that's in the dirt here attached to anything that's directly attached to the timber here. The timber itself is isolated at this level at the top of the plinth, but the grill here has to, if you like, cantilever off to not touch the building. Just as underneath the building, there's a sort of minimum of 500 mil crawl space underneath the bearers up here in this is the highest corner in the southeast corner of the building. The veranda roof, the low roof, was again put together in cassettes, much like the high roof, but these are obviously much lighter weight. These are only about 8 meters long, and they're on a 3-meter grid, so it's a relatively lightweight structure. So again, they're assembled on the ground and craned into position. And this is actually the system that we adopted for the Ravensthorpe building, which I'll show you a bit further down the track. The only part of this building that was actually carpentered in a conventional way was the garden courtyard, which you saw a little rendering of at the very beginning from the early model. So this is some of the drawings from that as to how that was assembled, just to prove to you that we can actually do regular joinery as well as regular carpentry, as well as machine processed carpentry. So this is the final outcome before the landscaping around the building was completed. In fact, that was something that the Shire took on themselves, and it's really only this year that it's actually gotten a little bit mature and a little bit sort of finished up. The sports hall here, top half of the cladding is galvanized iron, and this is the yellow stringy bark down at the bottom. That's that garden screen, the only piece of carpentry work in the whole building. And you can see here that actually, the different colors here represents the fact that has had a coating of oil and that hasn't at this point when the photographs were taken. The entrance through between the two buildings starts off very low on the town side and then scoops up to this funny kind of sort of frame that's looking straight at the center of the oval. I guess one of the things that we started doing on the South Hedland building, and which we've continued here, is that we kind of like to show the way a building's actually put together. So it's very raw. We're not trying to hide anything. There's no dressing to the building. What you see is what is kind of necessary to be there, and really not much else. And that's something that we aim to continue with. So this is the obviously the oval side. The town then actually had all their footy gear redesigned. Pingelly has a long history of football and of supplying significant players into the AFL. So they're pretty proud of that tradition. some more shots of that entry scoop, which has some of the kind of more eccentric structural work in it, I suppose we could say, than some of the rest of the project. Long veranda, which is on days when there's games being played there, it's now full. Buildings used for all sorts of things. This is Anzac Day. This is obviously a well-known gentleman, comes around the end of the year. Those of you in the Northern Hemisphere will recognise that we have Christmas in the summer down here. Little things, because of the way the roof is put together here, these columns are T-shaped at the top. So each cassette is separate. It sits on the haunch of the T and is complete this way. So there's a gap between the rafters, and we're able to slip some lighting into those gaps, get it out of the way. Just happens to make it sort of somewhat vandal-proof at the same time. That's that column head and rafter junction. There's some recycled timber in here in the bar, in the function centre. This is some jarrah that's taken out of an old building that was on the site before. All of the interior timber is treated with a mixture of tung and citrus oil. And we were quite surprised when the jarrah turned almost black under that treatment. Wasn't expecting it. It turns most timber darker, but wasn't expecting it to go that dark. I quite like it, however. There's that screen, 2 double layered at the top, single layer at the bottom. And there's every now and again there's another screen that pops up where there was some significant solar penetration to the club rooms here that needed shading. And again, that detail of keeping the ground away from the timber that has to run all the way around the decks. Sports hall itself, which is the sort of seems to be the money shot that people like for this building. When I say that you kind of what you see is what you get, the purlins that you can see, these are the bottom chords of the purlins that are supporting the roof. These ceiling panels are put up in cassettes that are about 1.5 meters long, complete with the insulation for the roof, and then they sit, if you like, on the flanges of the I-joists. And although they don't sit on the flanges of them here, we actually we fixed the sidewalls to operate the same way. They have to have a bit more screws, a few more screws in them, and there's an opaque translucent glass to the south side here, so that we get some relatively even lighting into the building. And this hall is used for all sorts of events, as well as the netball and various court games that are laid out here. This is the Australia Day breakfast, which attracts sort of 300 or 400 people each year. Schools now use it for performances and for their sort of ceremonial business. These deep edges are not actually structurally necessary. The columns could have tapered down to something much narrower at the bottom here, but we decided to keep them the same size because that actually gives this deep edge gives the building, it gives it somewhere to push stuff out of the way, but it also gives it a kind of gravitas that it probably wouldn't have, I think, otherwise. And acoustically, it's probably the best acoustic properties of any basketball or netball court in Western Australia at least. And that's beginning to be recognised, which I'm pleased about. Lights up quite nicely at night. This is the only deck that isn't protected at all, and it was an addition after the fact, which we advised against. But you know, it'll be fine so long as it's kept, as long as it's maintained. And at night, it lights up quite well. There's not a lot of light, but there's enough. And then outside the function centre, they have these long table dinners every now and again. It's really used amazingly actively by the community. So then lastly, and this is the project that's underway at the moment, and it presents, I guess, a different set of problems in a way to what Pingelly did, in that the program for this building is much more detailed, more complex than we expected when we started working on it, and it's certainly more complex than the Pingelly building. So this was the sort of early concept model, and these following on for it. So it was designed to be, you know, there's a kind of diagonal axis through here. There's an edge to the street all the way along here that joins council buildings to an existing community building. And you know, again, this is the sort of early Rhino model, with a central portal frame building with two side aisles spinning off it. This is actually where we're at now. This is the building that's currently out to tender, which is kind of not changed. It has changed somewhat, but not enormously from the original. Mainly what's changed is the way we're handling the structure of it, I guess. But we've maintained this diagonal kind of passage through here because there's a lot of activity in the town that goes on up here. So that's, I want to get onto this for a moment, because one of the things that is very different about working in this system of off-site fabrication and off-site preparation of timber is the sequencing and the kind of timeline of the building. So there's probably about 12 weeks of machining time to put all of this through the factory. So we encouraged the client to let the contract for the fabrication separate to the main contract of the building contract, if you like. We also encourage them to let the contract for the native timber. Again, this building will be clad and floored and decked with yellow stringy bark, much the same as the other one. We got that contract out first because we actually have to go into the forest and cut the trees, and then mill them, season them, or saw them, season them, and mill them. So there's a different kind of sequencing, there's a different kind of timeline that you need to observe. One of the things that we wanted to really de-risk on this project was being able to deliver all of the structural timber in the sequence that the builder, the contractor who was going to put it together, wanted it, and in such a way that they could start and just keep continuously working through the building. Because of the distance and the fabrication time that the Pingelly building took, there were gaps in the process that did cause some problems and some sort of time overruns, I guess. Although the building was completed in under 12 months in the end.
Patrick,
so
5 more minutes, please, and then we save a few minutes for question and answer.
Okay, I've just got a couple more slides I want to run through. So I think, you know, those are the kind of the main caveats which end up really influencing how you work through this whole process. The other thing, I guess, is that this building is modeled in Revit, whereas the other ones that we've done have all been modeled in Rhino. And I'm less impressed with Revit after this experience than I am with Rhino. It's you know, it's kind of clunky in comparison, I think, and you know, that's something that we should probably bear in mind the next time we do something. There's the internal courtyard of this building. This is again covered with a translucent sheet on this side, and then there's an external courtyard over here that's obviously more garden-like and has a sort of little performance stage in it. What was quite interesting when we gave a contractor briefing was that I need to. Sorry, I'm going to go back one. The contractors were very anxious to be able to see exactly what the timber built contract comprised, as opposed to the other, because there's a bit of other timber internal work that isn't appropriate to prefabricate. So we had to extract this model for them for that purpose. Now I'm going to show you a little fly through, if I can get my mouse back in the right place. And we'll drag this back to the beginning. Can you all see that now? What's on the screen?
Animation sequence.
Is that?
Oh yeah, I can see the video now.
That good? Okay. One of the big events in Ravensthorpe is the Wildflower Festival every year, which, you know, attracts this year, even in pandemic time, 6,000 people, 6,000 visitors, which for a shire of 2,400 people is a pretty big deal. Ravensthorpe is on the edge of the Fitzgerald biosphere, which is you know, world renowned and quite unique. So a lot of the planting that we'll be doing up here will be derived from the biosphere. It's not necessarily what we're showing in the drawings. There's a lot of screening to the west on this building where we can, and to the north. These columns and the rafters that are exposed to the weather around this courtyard will all be yellow stringy bark rather than LVL, but everything else is LVL. Of course, LVL is not good to expose it to the weather, so we try and, I mean, you can use H3 LVL, which you paint it up, but you know, if you want to withdraw, we try and reduce the maintenance requirements as much as we can. This building will be allowed to go grey, silver naturally, as will well, that was the intention with Pingelly, but they've actually been recoding it because they like the yellow color, which is fine. But you can just let them go, and there's enough robustness in the material where we've used it exposed for that to not be a problem. So it's a sort of multifunctional place. There's a visitor centre, which is the visitor centre for the biosphere. There's the council offices, kind of reorientated to be entered through here. Council chambers, community resource centre, which has library and all sorts of you know, government agencies, kiosks and what have you in it. There's a multi-purpose space for youth and for senior citizens and playgroups. There's some pretty nice facilities overall. We were very keen to have this colonnade that sort of edges the street. And this again is all, the colonnade is all in stringy bark because that faces south, so that'll get a lot of weather on it. Some Jarrah highlights around the entrance to the CRC. And that sort of shot goes straight through to the two courtyards. I guess while this is playing, Parisa, we could ask if there's any questions that. I haven't been looking at my chat line. I can't see. Sorry.
Sure. No, I don't think there is any question in the chat box, but I guess we can just open it to everyone. If you have any questions, please turn on your mic and you can just ask the question, or alternatively just type in the chat box and I'll be asking that from Patrick. I guess just a quick point, I think there's so much effort behind the scene, really. The use of timber, apart from mitigating the carbon, emissions and sustainable, I guess, impacts, has aesthetic justifications. The impact of, that light and shadow that that is really magnified through the use of timber, and you shared with us a few images. It's really so pure, and you don't think that you have done so much of intervention to the environment, so it's not very intrusive. So that was great. Thank you for sharing those projects with us, Patrick.
Thanks.
I have a question, but I let other people ask first. Ross, would you like to turn on your mic, please?
Yep. Thanks, Patrick. Love that story. And I've got a question. Have you had any life cycle assessment work done on this, or the?
No, that's something, Ross. That's something I'd really like to do, and I'm hoping that Daniel and I can start looking into that and get something really going. I'd like to get a proper carbon footprint assessment as well as a life cycle rundown. I think I can do the latter. I just need a bit of time.
Yeah, I think you absolutely must. It's such a fantastic extra dimension to the story if it's quantified in that way.
Yeah.
Signpost for the future. Thanks a lot.
Thank you.
Thank you, Ross. Anyone else? Okay, I just realized some people have just joined us. If you have missed the talk, this is all recorded, and you can refer to architalk.org, and the recordings are available there, so you can perhaps watch it at a later time. I have a question for you, Patrick. So what are the challenges when working with timber?
Probably the biggest challenge is actually, although it's getting better known, but persuading clients that it is a safe and reliable process to go through, or system to go through. And we've still got so little on the ground in WA in particular that you say build in timber and they say what? I mean, Pingelly was the largest all timber building that's been put up since the Meriden aircraft hangars in 1942. Well, they weren't, they're storage places, they're not aircraft hangars. There's a fair amount of glulam work around in various places, but there's very little whole building stuff in timber, and I guess that's that's what I'm interested in pursuing. From my point of view, if you can build it in timber, why would you build it in anything else? So the challenge is, yes, one is persuading your client. Two is the sequencing of the design and construction process. And ideally, you're working hand in glove with your engineering and fabrication team from the beginning, very early on. That's not always possible under the way that our industry is currently structured. If you follow a more or less conventional path, then, as I say, there's still a scheduling issue that needs to be addressed, because if you follow an entirely conventional path, and once you let the contract, most people expect building to start fairly soon. Well, it's not going to. If you've got a 12 to 14 week wait while fabrication takes place, so it really does kind of imply turning the industry standard mode of operation kind of on its head, and much more interdisciplinary collaboration, which I think can only actually be a good thing. When everybody understands what the issues are along the way, then you got a much better chance of sorting them out.
That's right. And I think with these projects and similar projects you are doing, we eventually can increase the level of trust and everything. I mean, the processes would be easier along the way, hopefully.
Yeah. I mean, every time we do one, we learn a little more. And we've done this last one differently from the way we did the Pingelly one. So there's a lot of refinement still to go. There's a lot of refinement in the fabrication process that can, it's happening constantly. I mean, the rapidity with which new engineered timber products are coming on the market is kind of extraordinary at the moment. I worry that we're not planting trees fast enough to satisfy the demand. And I guess the other thing that I would like to mention is that I actually dislike this term mass timber intensely, because it does imply that if you throw enough material at it, it'll all be all right. And that's kind of what CLT does. It uses an awful lot of material. And I don't think you gain that much from it. Certainly there are applications where CLT is a much more efficient material than, say, a framed cassette would be. But I think I think it behoves us to use timber as economically as possible, rather than just to use it sort of easily.
Sure. Yeah, I guess Tristan has a question. I think we need to wrap up, but we'll let Tristan to ask his questions, please.
Thanks, Parisa.
Hi, Tristan.
Hey, Patrick. Thank you for that. It was fantastic. One question I would have, and more I'd like you to comment on, is how well positioned our educational institutions are to work within, I guess, this emerging space of timber buildings, and whether we need to increase the literacy of our students in fabrication as well as material, and in the digital kind of workflows.
I'd really like to see that happen, and I think it's very necessary, because if our profession isn't familiar with the processes, and more than familiar, doesn't hold the expertise that they need, they're not going to get into this, this area of work. And you think about the sort of the journey that we've been on. I mean, it's consumed the majority of your career, both as a student, as a postgraduate student, and as a professional. And you become aware of how much more there is to do. Likewise with me. I don't think our architecture schools are anywhere near delivering the kind of level of instruction, the level of technical instruction that is necessary to function in what is a very different industry and profession now, to what it was when most of the people who are teaching either practiced in it or were kind of learning it. So yeah, we need a complete, I think, revision of the architectural curriculum, because not only it's not just about timber, it's about the whole fabrication and construction industry. And I think it's about time that architectural education actually started talking about construction again, rather than sort of leaving it to somebody else. Because I have this sort of sneaking suspicion that architects are actually getting more ignorant rather than more intelligent.
Thanks, Patrick. I guess this is a conversation for us to continue, really. We will be,
I think so.
Yes, definitely inviting you for that conversation later on. I would like to thank you again. That was fantastic. Thanks for sharing your works and insights with us. And thank you all of the participants for their time. Have a great day.
Thank you.
Thank you. Thanks, everyone.
Thanks. Cheers.
Bye.
Bye.
Thanks, Patrick.